Assalamu alaikum warahmatullahi wabarakatuh. Let's continue our talking about the completing square. We have talking about the introduction for the meaning of completing a square and how can we complete any binomial to be a perfect square. Okay, so we have here this question, factorize each of the following. So I want to factorize them. What is the meaning of factorization? It is the opposite of distribution. It means I want to convert this expression into two factors times each other. These two factors can be two brackets or more. It can get GCF or whatever we have here. Okay, now we have a binomial and we have talked about that when we have a binomial, so it can be a perfect, it can be, difference between two squares, and it means I can get the square root of the first and the square root of the second, but the middle sign has to be minus to get the difference between two squares, or sum and difference, or difference between two cubes. So we have here any cubes? No, this number I can't find the cubic root of x to the power 4, neither for the 4. So what shall we do here? If we don't have a difference between two squares, or we don't have sum or difference between two cubes, and we have here a binomial, so we are going to using the completing the square strategy. So now we have the first term, and we know that the first term, because we have here what? A perfect square number, and it has, yes, it has an unknown. And how can we get the square root of this number? Okay, the square root of this number equals 9x to the power 2. And we have here, this is the second term, or the middle term, or the last term. Yes, this is the last term. How do I know? Because it has no variable on it, and we have here a perfect square number. Again, we can find the square root of this number. Yes, it is 2. So if I want to complete this binomial to be a perfect square, how can I solve it? I have to get a middle term. How can I find the middle term? Well, the middle term equals plus or minus 2 square root of the first term times the square root of the third term. So we have here 2 times square root of the first, which is, yes, 9x to the power 2. And the square root of the third is 2. 9 times 2 equal 18. 18 times 2 equals 36 x to the power 2. So this is the middle term which I want to add to the binomial to get a perfect square. Now we have here what? 81 x to the power 4 plus 4 equals, I will keep the first term as it is, 81 x to the power 4. Then I have to add in the middle term which I got here, which is plus 36 x squared. Miss, it can be plus or minus? Yes, it can be plus or minus. But remember, when we want to complete the square, the last step has to be difference between two squares, just like the previous video as we discussed together, to be able to completely factorize the expression. Then let's put the third term, which is 4. Now I add a term to keep the balance of this expression and to don't affect the result of this expression. Wherever I add, I have to, yes, subtract. So 36x to the power 2. Now these three terms, or trinomial, represent what? Represent a perfect square expression. So the first term here, the square root of it, yes, 9x to the power 2. The square root of 4 is 4, and I will keep it by the middle, yes, the middle sign. Then let's drop the last expression as it is, which is minus 36x to the power 2. Now I have difference between two squares, yes, because I can find the square root of the first term and the square root of the second term. Okay, so in the difference between two squares, what shall we do? I will open two brackets. One of them will have the plus, and the other one will have the minus. Then the square root of the first is what? I will cancel this 2 by this square root. It will be 9x squared plus 4. And here will be the same first term, 9x to the power 2 plus 4, minus the square root of 4 is, of 36x squared is, yes, 6 x, and here 6x. If you want to arrange them, it will be better, of course, to arrange them. So we can arrange each trinomial in its brackets. It will be 9x to the power 2 plus 6x plus 4. And here 9x to the power 2 minus 6x plus 4. Do we have to do that? No, it's not. You don't have to do that, but it's better, of course, to keep it as arranged trinomial. Okay, now we have number 2. In number 2, as you can see here, I have a trinomial. I don't have any binomial. Okay, so what shall we do in the binomial, in the trinomial? Well, the first step, I have to check if we have any GCF. Do we have any GCF here to take away? No, we don't have GCF. Okay, can I make it as a perfect square? Because this is the first special case we talk. Okay, the square root of the first is x to the power 2, and the square of the last is 8y to the power 2, and the middle has to be what? First times second times 2, so it has to be 16x to the power 2 y to the power 2. Once you see here the middle term is smaller than the supposed term we will have in the perfect square, so be sure that you will need to use the completing square. Messed up, we can use AC method. Okay, if you try it. Okay, so the AC here equal what? Equals 64. Okay, what are the two numbers? If you multiply them together, you will get 64, and the sum of them equals 15. Do we have any factors for 64? If we add them together, I will have 15. No, I don't have it. So what shall we do here? We have to complete the square. But yes, we have the first term as this, and we have the third term, and also we have that second term. So what shall we add to this trinomial to make the perfect square? Well, do you agree with this middle term? This middle term satisfies the conditions of the perfect square? No, we have to replace it by 16x squared y square, or 16x to the power 2 y to the power 2. So what shall we do here? I will write the first term as this, okay, and instead of our middle term we will put, yes, plus 16x power 2 y to the power 2. Then the last term will be as this, which is plus 64 y to the power 4. So what we do to this one, I have to keep it, right? So it's a part of our trinomial, so I have to keep it again. Okay, 15x squared y squared, and wherever we add, we have to, yes, we have to subtract. So we'll subtract minus 16x power 2 y to the power 2 equals, now this trinomial give me a perfect square or not? Yes, it gives me a perfect square. So the square root of the first is x to the power 2. The square root of the last is y, 8y to the power 2, and the middle sign will be plus. And here 15x power 2 y power 2 minus 16x power 2 y power 2. They are like terms or not like terms? Yes, they have the same variable by the same exponent. So what shall we do to the factors? Or for the coefficient, we will add or subtract. 15 minus 16 equal minus 1. So it will be minus x to the power 2 y to the power 2. Now we have difference between two squares. Yes, we have. So open two brackets. One has plus and one has minus. And let's find the square root of the first is, we'll cancel the 2. It will be x to the power 2 plus 8y to the power 2. And the other one will be, yes, xy, because the square root of x squared y squared will be xy. Here it will be again the same first and second term, and here we have xy. What shall we do here in this equation? I want to solve it. Well, of course, when we have different exponent for the same variable, we have here x to the power 2 and x. We don't have the same variable by the same power. If we have the same exponent, we will solve it as we learned before. but I have here two different terms. I have x to the power 2 and x. So what shall we do? I have to factorize this term to be able to find the value of x. Okay, how can I factorize it? Well, let's find out if we can find any GCF. No, we don't. So is it a perfect square? I can find the square root of this number, but I can't find the square root of this number. Okay, so let's factorize it as we learned before. So what are the two numbers? If I multiply them together, we'll get 3, and the sum of them will be 8. Do we have anything like that? Of course not. 3 is a prime number, has only two factors, and if we add them together, it will be 4, not 8. So I can't factorize it by any way that we learned before. So what shall we do? Yes, I can hear you. So we are going to complete the square. So this time, I can add the middle term. Let's see. I have here what? X to the power 2. Yes, I can find the square root of it equals x. What about the third term? Can I find the square root of the third term? No. So what shall we do here? We have to replace the third term. So this time, we have to replace the third term. We have to complete our perfect square by finding the value of third term. But how can we find the third term? Well, some of us can find it mentally. It means I know that I have here x times something times 2 equals 8. So mainly x times something equal 4. So this thing will be what? Will be 4? No, it will be the square of 4, which will be 16. So if I replace 3 here by 16, I can find the square root of 16. It will be 4. 4 times x times 2 equals 8. But sometimes you will get confused or you don't remember. What shall we do? So we have here a beautiful rule to help us to find the third term. What is this rule? This rule tells me that we can find the middle, 2 to the power 2, over 4 times the first term. Okay, the middle term here is what? Negative 8x, all of it to the power 2, divided by 4 times the first term, which is x to the power 2. Okay, let's square. Negative 8 to the power 2 equals, equals 64. X to the power 2 divided by 4, x to the power 2. Okay, cancel x to the power 2 by x to the power 2. 64 divided 4 equals, equals 16. So the third term which I want to add is what? Is 16, as we figure out here. So what shall we do here? Let's rewrite our equation. So we have x to the power 2 minus 8x, and then I will replace the 3 by, by plus 16. It has to be positive this time, right? I can use any negative number. Okay, and what about the 3? It's a part of our equation, so I have to keep it. And wherever I add, I have to, I have to subtract, because I want to keep it balanced. So minus 16, all of it equals 0. Now this trinomial can give me a perfect square number, or a perfect square. It's a perfect square. So open the brackets, and let's find the square root of the first x. The square root of the last is 4, and I will keep the middle sign, which is minus all to the power 2. 3 minus 16 equal negative 13. All of it equals 0. So what shall we do next? It's not a perfect difference between two squares to analyze it more, but let's look closer to this sign, or to this brackets. We have here what? X. Only x. I don't have two different terms by x, or I don't have different power for the x. So I can use the previous knowledge as we learned before. How can we solve an equation? What does it mean? Let's keep this one, x minus 4 to the power 2. And I want to get rid of anything beside the x to find the value of x. So let's throw this one to be in the opposite side. It will be by the positive, of course. It will be 13. So if it goes here, it will be 13. 0 plus 13 equals 13. Now we have what? We have the square to the power 2. What is the opposite of the power 2? The square root. But we have something very important. It will be attached to the square root if you want to use the square root. It will be plus or minus. It means positive or negative. So what is the square root of this sign? It will cancel the 2. So it will be x minus 4 equals positive or negative the square root of 13. And remember, I want the solution set in R, and we know all that this is what irrational number, so it's belongs to R, of course. Now I got x by itself in one term, or I still have something beside x. Yes, I have -4 beside it, so let's throw it away by the positive. It will, so x equal positive or negative square root of 13 plus 4. So now I can write the solution set equals what? The solution set equals square root of 13, which is positive, plus 4, or negative square root of 13 plus 4. Okay, that's all for today. Thank you and see you soon, inshallah.